Welcome to The Explainer. If you're working in C++, you're constantly needing to store lists of items. Now, the old school way to do this is with a raw array, but the modern, safer, and frankly more powerful way is a vector. Today, we're going to break down exactly why you should almost always choose the vector. So here's our game plan. We'll start by really understanding the classic C-style array and, what makes it so fast. Then we'll get into the dangerous traps it can set for us programmers. After that, we'll introduce its modern replacement, the awesome STD vector, see how it works its magic under the hood, and then put them head-to-head to see why the vector is the clear winner for modern C++. Okay, first up, what is an array? Before we can really appreciate why vectors are so fantastic, we have to understand the foundation they're built on, the raw C-style array. At its heart, an array is really just a row of boxes, all the same size, stored right next to each other, side by side in your computer's memory. This concept of being side by side, or contiguous, is the real secret to its speed. And here's what that looks like in actual C++ code. We're essentially telling the computer, hey, give me 5 boxes that can hold integers, and then we're just dropping our values right into them, all in one neat, continuous block of memory. So why is this contiguous layout such a big deal? Well, because everything's in a neat row, the computer doesn't have to hunt around for each element. It knows the starting point and can instantly calculate where every other element lives. This means access is just incredibly fast. And this is how it works under the hood. The computer just does a tiny bit of simple math. It takes the memory address of the first element, adds the position you want, the index, multiplied by the size of each element, and boom, it can jump directly to the correct spot. No searching required at all. And this is the brilliant result of that formula. O of 1 time complexity, which you'll also hear called constant time access. In plain English, that means it takes the exact same amount of time to get the last element as it does to get the first one. It is the fastest access you can possibly get. All right, so it's fast. But all of this raw power comes at a price. Raw arrays have some really serious dangers that have plagued C++ developers for decades. First off, we have the classic static array. Its size has to be known before you even run the program. So if you need space for 5 items, you declare 5. But what if the user wants to enter 10 or 100? Well, too bad. It's just incredibly inflexible. Now, here's a huge trap that catches everyone at some point. What happens if you have 5 boxes, but you accidentally try to write something into the 10th box, a box that doesn't even exist? Well, unlike many newer languages that would stop you dead in your tracks, C++ just trusts you. It assumes you know what you're doing and will happily let you write data way outside the memory you actually own. This is what we call undefined behavior, and it's a programmer's absolute worst nightmare. You might be overwriting another variable or corrupting a critical piece of the program's memory. The program could crash, or, and this is the really scary part, it could just produce the wrong results silently, leading to bugs that are incredibly hard to find. The old workaround for flexible sizing was to use dynamic arrays with pointers, but this just traded one problem for a whole bunch of others. Now you're in charge of memory management, which is a major source of bugs like memory leaks and dangling pointers. It's a real headache. So with all these problems, C++ needed a better way. And that solution is the STD vector, a modern container that gives us the best of both worlds. I mean, this slide just says it all. On the left, you have that messy, dangerous world of manual memory management. And on the right, you have the clean, safe, and automatic approach of STD vector. It just handles all the complex details for you. So how does a vector provide all this safety without sacrificing the raw speed of an array? Well, it's not magic. It's just really clever engineering. Let's take a look at how it works. Okay, the most important concept to wrap your head around is the difference between size and capacity. Size is easy. It's just how many items you've actually put into the vector. But capacity is how many boxes it has allocated in memory, ready and waiting for future items you might want to add. So when you try to add an element and the vector's full, it automatically does this little dance you see on the slide. It allocates a new, bigger block of memory, often doubling the capacity to be efficient, copies all the old elements over to the new spot, and then frees up the old memory. This is how it grows dynamically without you having to lift a finger. And here is a great pro tip for you. If you know ahead of time that you're going to need space for, say, 1,000 elements, you can use the reserve function. This tells the vector to get all that memory in one single go, which helps you avoid all those costly reallocations as you add elements one by one. It can be a huge performance boost. Okay, so we've seen the mechanics. Now let's put them side by side for the final showdown and make the right choice completely obvious. This table makes the conclusion crystal clear. While raw arrays are fixed and force you to handle safety manually, vectors are dynamic, safe, and resizable by default. For modern C++ development, the vector is the hands-down winner. And this isn't just academic theory. These fundamental data structures are the workhorses powering so much of the technology all around us, from character inventories in the video games you play, to the pixel data in image processing, and even the massive tensors used in AI and machine learning. So the key takeaway is this. You should understand the raw array because it's the foundation of everything. But in your actual code, you should almost always prefer the modern tool, standard vector. It gives you the performance of an array with a critical layer of safety and convenience that just prevents a whole class of bugs. And this leads to a final, really powerful idea. The vector is a smart wrapper around a raw, dangerous concept. So think about it. Where else in your code could you apply this same idea to improve both safety and performance? Thanks for joining me for this explainer, and keep thinking about how you can write safer, smarter code.